Hello everyone. In this video, we are going to talk about a problem that we got from Berkeley Math Tournament from February 2021. For more information about Berkeley Math Tournament, please see the description of this video. In this problem, three mutually externally tangent circles have radii 2, 3, and 3. A fourth circle, distinct from the other three circles, is tangent to all other three circles. The sum of all possible radii of the fourth circle can be expressed as m over n, where m and m are relatively prime positive integers. We want to compute m plus n. Before moving to the solution, make sure that you pause the video to think about the problem. Before talking about the solution, we first need to understand how many circles we can have for the fourth circle. There are actually two possibilities. It can be either a small circle externally tangent to all three circles, or it can be a large circle internally tangent to the other three circles. Let's use D for the center of the small circle and E for the center of the large circle. We also use A, B, C for the center of circles A, B, and C. Now let's construct triangle ABC, and then we are going to draw CE, which is basically the height of triangle ABC from vertex C to base AB. Note that the center of the large circle E is actually the intersection of the height CE and AB. It's simple to show that it cannot be the other case. Now we are going to write some equations. In triangle CBE, we know CE is equal to SQRT of CB squared minus BE squared. For CB, we can write the radius of circle B plus the radius of circle C. And for BE, we are going to use radius of circle B. If we replace the values that we have, we will see CE is equal to 4. We also know CE is equal to CD plus DE. Since CE is equal to CD plus DE, we can replace the value that we have for DE in triangle BDE as SQRT of BD squared minus BE squared. For BD, we are going to write it as the radius of circle B plus the radius of circle D. And for BE, we are going to write it as the radius of circle B. For radius circle D, we use R1. If you replace all the values and then solve the equation, we can find R1 as equal to 2 over 5. Similarly, we know C is equal to 4. And CE is actually the radius of the large circle E minus the radius of circle C. We use R2 as the radius of circle E. If we replace the values, we can see 4 is equal to R2 minus 2, or R2 is equal to 6. Now we have R1 and R2, and we want to find R1 plus R2. If you add them together, R1 plus R2 is equal to 32 over 5. From the problem that we have, R1 plus R2 is equal to m over n. And we know m and n are relatively prime. So m should be 32 and n should be 5, because you cannot just multiply m and n by a number. Otherwise, they are going to have GCD not equal to 1. So m plus n is equal to 37, and that's our answer. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel.